All right, welcome everyone. As a reminder, we have a quiz coming up on Friday. So please check out the practice quiz and so you know what questions you want to ask about in class on Friday. Are there any questions about the project proposal?
I do, but just get more of them ups and downs stuff. So we need to figure out how we're gonna randomize them.
Okay,
So.
but you feel like that's a more specific question to your data set?
Yeah.
All right, I can come talk to you about that during group work. All right, are there questions about the homework? Allison.
For homework 17, do problem 5 part D.
Homework 17, problem 5, part D. Okay, so this is, we are looking at the proportion of all adult males between the ages of 20 and 34 who have high blood pressure. We want to find a confidence interval, so a 95% confidence interval that's accurate to within 3 percentage points. And we want to know what sample size we should use. So for this problem, we're trying to estimate a proportion. So what formula for sample size do we use? Sarah?
It's P hat times 1 minus P hat times the multiplied divided by E squared.
Very good. All right, so for this problem, we were told that we want to be accurate to within 3 percentage points. So that's saying that E, our margin of error, is going to be 0.03 because we need our 3 percentage points written as a proportion, as a decimal. So 3 divided by 100. And it's because it was within 3, that means it's okay to be off by 3 in either direction. So 3 percentage points isn't the width, 3 percentage points is the total margin of error. So we don't need to divide by 2. The staff believes that the proportion of male UWEC students with hypertension will be close to the proportion of males between the ages of 20 to 34 with hypertension found by the CDC. So that's telling us our value of P hat that we want to use is going to be the value from part A, was our point estimate. So 58 divided by 678. And then for the multiplier, that's going to be based on our level of confidence. So we want 95% confidence here. So that means we've got a normal distribution. We want 95% of the data in the middle. So a total of 5% in the 2 tails. So 2.5%. Or 0.025 in each of the 2 tails. So what calculator function are we going to use to find the threshold, the cutoff value that gives us that? Inverse norm. Yeah, so we can do inverse norm of 0.025 or of 0.975 to get the upper threshold. And remember that when we're finding a sample size for a confidence interval, to find the multiplier, we always use inverse norm with a mean of 0 and standard deviation of 1. So that way our multiplier has the interpretation of how many standard deviations away from the mean do we need to be to contain that much data. Does that answer your question?
Yes.
Cool. Other questions about part B here? All right, Sandra, I think you would raise your hand for a different question?
Yes. Person 16.
And which one?
Problem 2.
Problem 2. All right. And you were asking about finding point Y? Excellent. So a key idea here is that in order to figure out if something is an outlier, we need to calculate the fences. So we talked last time about the upper fence being the third quartile plus 1.5 times the interquartile range. And the lower fence being the first quartile minus 1.5 times the interquartile range. So anything outside of these fences, so greater than the upper fence or less than the lower fence, is going to be an outlier. But the key idea here is that the whiskers on the box plot this is the same direction as the problem. The whiskers do not actually go to the fences. The whiskers go to the last data point that is not an outlier. So if you find that uh, 0.266 is an outlier and 0.270 is not, then value Y here at the bottom of the lower whisker would be at 270, not at 268.5 or whatever it is you find for the lower fence. Sandra, does that answer your question? Cool. Other questions about problem 2? All right, other questions about the homework? Allison. Homework 17, problem 1C. Okay. So did you have a question about how to get started on this one, or you tried it and it didn't accept your answer?
I tried it and I didn't use the right like calculator.
All right. So this is dealing with today's material. So we talked about doing theory-based hypothesis tests to compare two means. And we also talked about doing theory-based confidence intervals to compare two means. So here, we're being asked to find a 98% confidence interval for the difference in means of the ages of students' cars minus the mean of professors' cars. So what calculator function did you see in the video for today about finding that confidence interval? Ready? Yeah, that's a 2 sample t interval. So that goes along with the 2 sample t test. It's just the confidence interval version of analyzing the same research question, same pair of variables. So here we'll use a 2 sample t interval. Let's grab a fresh document. And the information we need to put in for this, oops, is going to be X bar for group 1, S subgroup 1, so the sample standard deviation for group 1, and the sample size for group 1. And same thing for group 2. And then we need to put in the C level, which is the confidence level. So here we wanted a 98% confidence interval. So our C level is going to be 0.98. And then for entering in your information, your statistics about the sample, your calculator is going to do group 1 minus group 2. So in order for your results to match what the problem is expecting, you're going to want to enter in the students as group 1 and the professors as group 2. If you do it backwards, it's really not a problem. It's just that you'll need to multiply your endpoints by -1 and then just reverse the order of them. Allison, does that answer your question, or did you want to go through the specific values?
No, that.
All right, cool. Any other questions about the homework? All right. I wanted to spend some time talking about the haircut price simulation that we worked on yesterday. Or yes, this was Monday. Yesterday. Let's see. So let's skip down to problem 4. What was the difference in sample mean? So the sample mean for females minus the sample mean for males. Mary, what'd you get?
32.28.
Nice. And do you remember what part of the applet you looked at to get that answer? Okay, so the observed difference. kind of right at the bottom of the applet after the table. It'll give that to you. Did anybody find or figure out this answer in a different way? Sarah?
I think it was the down in the table. I don't remember which ones, but I have that I subtracted two numbers and got it. So.
Yeah, so the other way to get the same answer, open up the table or open up the. So you can get the observed difference right here, or the other way to get it is by looking at this table and taking the mean for females minus the mean for males. And that will get you the same answer out to the number of decimal places that it gives you. All right. So what are two possible reasons why that difference of sample means doesn't equal 0? Mary?
That female haircuts.
Yeah, so we might have, let's grab this. So it might be that females' haircuts really do cost more than males. So in other words, that the difference in population means really is different from 0. And the sample we got accurately reflects that. So, I mean, we could get into more specifics about why females' haircuts really do cost more than men's. But this is sort of the very broad possible explanation, is that there's some real difference in the populations. What's the other possibility if this is not the case? Okay.
The actual population is the same, but we just happen to get a sample that has a different symbol.
Yeah, so the other possibility is that there's nothing that's really different about the populations. So if we could measure everybody, survey everybody and ask them about the price of their last haircut, we would find that the difference in population means was 0. But we happen to get a sample that has X bar female minus X bar male not equal to 0 by random chance.
as sufficient, and we just said because of sampling variation with oscillations in the air, that still means something? Or do you want us to like say like more specific?
So I think if you said like mu sub female minus mu sub male equals 0, but there is sampling variation, that would be fine. All right. So then how is the applet going to help us decide between those two reasons? Let's do table 2. What'd you say for part 5B? What'd you say for 5B?
I focused on outliers.
All right. What's that? All right.
I can talk it through. We're simulating the null hypothesis, which is there is no difference. So the statistic we find should theoretically match being 0 in our p-values that prove the null. But if there is a difference, then it's not going to match. It's still going to be
Yeah. Mary, do you have something to add to that?
just kind of like a let's just say like calculating the value. So it'll tell us how like about it. That's 32.28. There's no association with each other.
Yeah. So the simulation is assuming that the null hypothesis is true. So the simulation assumes that there is no difference in the means. And then the p-value will show us how unusual something that's as extreme as 32.2 would be if there was no difference in the population means and all that was going on was sampling variation. Or something more extreme. If all that was going on was random sampling variation. So the idea is that if it's really surprising to get 32.208 just due to random chance, then we can rule out the possibility that it was due to random chance. So we can rule out that second possibility that we wrote and conclude there's enough evidence to say that there really is a difference in the population means. All right. So let's skip down to what p-value did you get? Table 4, what p-value did you get?
0.000.
Other tables got something similar? Probably not exactly the same, but same conclusion. All right, and table 4, how did you phrase your conclusion based on that?
There is very strong evidence that there is a positive association between gender and hair.
Between gender and haircut price? Yeah, I think if we're saying positive association, I would probably clarify like which way the association went. So I might say between being female and haircut price. Did anybody phrase their conclusion differently? Sandra, what'd you say?
I said there's a very strong association between gender and price of haircut. Females tend to pay more.
So we could say there's very strong evidence that females tend to pay more on average for haircuts. Nice. Anybody else phrase it differently? All right. Are there any questions about this activity, or perhaps any of the questions that we skipped up here? All right. So now we get to try comparing two means using a theory-based test. So using a two-sample t-test. So give this a try. Check out whether John Grisham uses longer sentences in his books for adults than in his books for teens. So for folks watching the recording later, this is the John Grisham activity.
I mean, like, you know, like it's a confession for adults, so like if I was like writing out, I read confession that just. You know what I mean? I feel like it's not so when we use your marketing that on there was, you know what I mean? Or is it? I think it's like the average of all. You know, you're right, actually, yeah. And that means the confessions. So this would be. Yeah. Oh, yeah, these one. what's the sample?
This is population.
Are they the same?
Yeah. Break down. Oh, because we have to check. Because it's gonna be two samples. What is
Yeah.
All we're fine with because it's two samples and because that's what I wanted. So two samples, so it's not a winter process. That makes sense. So like it's like your the metric oh, it's a lot. It's like one solid number. I mean, you should probably write the confession and then do your vote, but I know that I need that.
Yeah, so I was just wondering if I'm just gonna write C for the
Yeah, I think as long as you understand what it is, and then on the be more specific.
Get voters.
You just look at. So like that, be like the same level, and then go population. We're trying. Oh. Comment on the actual. I'm gonna say probably appropriate, it might have been not strongly skewed and. There's way more. Yeah. Well, yeah, how about time for you guys? Yeah, we have to do.
I thought it was.
Oh. Well, we have to compute the, I guess you have to compute the standard deviation. Oh. And then you use the calculator to do the. X bar is the sample mean, and then use the population. I didn't know, do you guys be more specific than that, or?
So what is the population in this case?
All ones of
For adults.
Yeah, so it needs to be all of his for adults, or to be all the words, all the sentences in the confession.
Okay, that's what we should say.
all words in the sample.
Right, she didn't count.
Yeah,
all
this
of the
should have the whole
sentences
book.
in the
So all.
Is it, so it's all words or sentences?
all words, shorter sentences, kind of the number of words in each sentence.
So all words in sample.
It's the mean length of sentences. Sorry.
The Grisham. And descriptive statistics.
Just.
She said this.
That is not the answer. Whoa.
Use that.
Doesn't matter.
So it's there's more than 20. There's more than 20.
But no,
It's not, oh yeah.
that has to be.
But it's not.
And we use two tests with me.
I would say so. Like,
Maybe a two, these are.
but I mean,
So,
this is a chunk.
And then you have the-
Yeah, okay. Would you call that strongly skewed or just moderate? For the validity.
So I would say that that is somewhat skewed. What were the sample sizes? And between each group, it's like 40 or something like that. So I'd say that's probably okay. It might be a case where I want to do the equity and the two sample two test.
So it's somewhat skewed, but because there's more information, it's sort of not.
Yeah, it's okay.
And that should probably be one. Okay.
Did you check this? What would be the second one? Yeah, that way you don't get.
I mean, that's still. So just do both tests. It's okay. It's not perfect. I mean, both can be good.
Yeah, but sometimes with real data, it's almost never really clear.
Yeah. Alright, it's not the box quality, it's not the.
It's not too strong. Oh, it should be.
You think they're different?
No, so it should. No.
I just heard it should be different.
I don't think they're not that far.
Yeah,
So it's right now.
The beans are here.
I'm just gonna just get.
Yeah, if you go to separate that.
Okay, these other needs, yeah, you can check books.
Data.
Yeah.
Yeah.
There's eight that are in the down.
So.
So you.
It's the kids. But that's. I would say that this singular outlier makes it strongest. It's over. Oh, what's the?
Oh, it's just the bottom one.
Not the.
Slow rating.
You need multiple outliers for a.
I think just everything else.
Oh, yeah. It depends on what's going on with the rest of the data, and it depends on how far an outlier is.
Test.
This might be an else where I might want to. Here, two samples of test and the output.
Done. Or the down.
Broadly.
Because my idea is not hard to. So.
Wait, isn't this supposed to be because it's from our own? You entered that
Oh.
for X one. I was just thinking
Thank
like
you.
because that one had it reversed. Like, yeah, I think that's what it is.
Yeah, no, that's.
Hey, what's that?
And it's the same size.
89.
29 for.
Don't tell me the answer yet.
What? I'm not saying that. I don't know.
Oh, thanks. Cool. No.
Bottom of my nose.
Oh my God.
Alright.
It should be bigger.
How big?
Big.
That big is 8.83247.645.
That is exactly.
Okay. We're gonna be like 3x. Just because.
So
Five.
Makes sense. Sure. Relatively the same, yeah.
Because the observed.
I don't know, I think it was or at least the median.
Maybe.
Well, that just makes sense.
Because.
It's what the alternative hypothesis is, because we didn't do it.
The bees is something that-
We're gonna get two-sided on our No, we're not, we're gonna one side, which means it's gonna be strong. Just like, just not equal.
Does not equal.
You know, like how like, when you just like, well, it's not as strong.
She's giving us a hint.
As if you do like a lesson.
Yeah, so if we're to do not equal to, then the p value will be even larger. That's all.
It's just more. I don't know. I don't know.
No, I see the hint, I don't get it. The value of blank. The direction.
Saying because our median is larger than the digit.
So.
They're switched.
Alright, you can just say,
So that's why there's not.
say if we swap the alternate symbol out,
that's if you wanted to.
or like, or we just say that go to this larger sense. Then maybe the p value might be like this.
Make a guess and then put it back.
So we figured we, and we felt that discussion.
We didn't think that.
Well,
Order it on the sheet, like if they were the
well, we were
opposite,
testing.
we probably would have had way better.
Okay, so I would say that.
Just say the lower line had a larger mean.
Because they have larger involved.
The convention, yeah. It would be,
If you would prefer to spend this time talking about your project.
Oh, yeah,
you'll
we
see
do that.
about that too. Beautiful.
Fire sounds good. Yeah, well,
You have your last time.
I
I
guess.
mean.
Okay.
Sure.
Alright, so we like. Actually, 1,000. So we have a way to randomize this. So like 3 random 1,000.
And I feel like random sampling is what you want as opposed to restricting one of the variables and saying, we're only gonna look at.
I actually needed that so much.
Do you want to take a random sample or do you want to restrict your analysis and say, I'm only gonna look at urban points, we're only gonna look at.
Well, what you see is that it has like a bunch of schools all combined. So we're going to select it randomly from like all schools, or we're going to select like so maybe a certain school.
So tell me what the data set is.
It's like where we got it.
So yeah, it's like a post pretest and a post school, and it shows like the size of the class, like all the things. And that's what we do post test was, we're trying to compare and see what that size of class and what we're schools like that. I see what that's there. And the problem is there's has like so many schools and as the data, we don't know if we should just randomly pick out of all of them, or like six trees, like a couple schools. We don't know. Like one, 3 of the schools are here, so or high school, college, so we just realize.
Probably want to like randomly generate.
Yeah, that sounds interesting. So if you want to,
Like if I
randomize it in Excel, equals random.
I can use that engine spreadsheet.
Yeah, it's not like that.
It's like, copy paste the first thing.
Close the parentheses, yeah.
But not all of this stuff. I thought you were gonna do something.
And then I didn't want to come that cell and then drag it down there.
Yeah, but she doesn't like those.
Get a mouse.
Yeah, so I just need to know what
And then
it's like.
close by that color. Random numbers. No, data.
I have a really long. We can do like.
Or do you want to do something like that? Wait, what is it?
We want like.
Your problem is to make a budget. Well, we want just what we're making. So we want just the. Legal girl,
So my values and it's small.
I think
I mean, that's not.
So the funny thing is that every time you do something to the random numbers change.
This number's one.
Yes, because when you sort it, it randomizes the numbers.
Just take the first time.
Delete everything after.
Yeah, highlight everything below. That's awesome. Yeah, like we don't have
Like,
back to the thousand.
Like, that's so much, like, why don't we so short of 20 bucks? Like, still.
Oh, come on, you just hit yourself in the face.
They're crying now.
Just get your eyes.
It might be good to print out. Like,
Oh, here's the.
Oh, yeah, we used the two sample interval thing. Yeah, I was in the process of doing that, then I, like, I'm in gym, it's good that I can enter the schools and choose how to choose category.
Yeah, like,
Cause I was telling like the reason why we was sort of stuff, like, they had to go out to school to do some randomized.
At least I'm pretty sure that's right. The only thing that's wrong is if it's short.
That's wrong. Since it says if there's time, but it won't be. You guys can answer. You guys watch my own. Like I started with a video, so I just kept saying, oh, I'm not gonna watch it, because I'm not getting it. So I turned it on, watch the movie.
Dang, I just put my folder away.
I'm waiting for something to happen. It's so much of a, see what I do, it's like, watching this and when I listen to my. Right where I got all the words and I should go over myself.
I guess.
oh, that's what I'm doing.
I just like skip through it, but
I'm done watching these videos. I'm just starting to do
It's gonna be a smaller number.
Yeah, I need to like.
It's gonna be like 2 versus.
Oh my god.
Oh my God, I need that.
That's all I got.
But like, you have a plan.
I have no idea, guys.
I'm fine.
I was literally just doing questions inside that circle.
Who knows?
What is that? What's the name of that?
I moved from. Oh, yeah.
I know it's hot one.
It was like an interpret. I was like, shoot. And then I had the interpretations on the video. And I was like, oh. I was like, perfect.
All right, we are about out of time, so we will talk about this activity at the start of class tomorrow. Have a good afternoon.
So.